Friends, today we're going to talk about solving inequalities that have an absolute value sign. Remember, the absolute value sign kind of looks like two lines, I guess. Then we'll have something on the inside like x plus 3, something like that. And recall that absolute value means the distance away from 0. When we're solving these, the first thing we want to do is isolate the absolute value symbols and whatever's in them. And then we're going to split the inequality into two separate inequalities, because like a negative value can be 10 away from 0, let's say, and a positive value. So we're going to split it into two separate inequalities, one of them being equal to a positive number, one of them being equal to a negative number, and then solve those. We're either going to have less than or greater than. If you have less than, like these first examples, then that is similar to an and compound inequality. So if we start with the absolute value of x less than a, then we can split that up into saying that x is between positive a and negative a. So let's look at an example. First thing we want to do is we have to get this part of the expression all by itself. So we're going to add 1 to both sides. And we get the absolute value of v minus 3 less than 11. Now I can split it up because now I have the absolute value portion isolated. And to split it up, I'm going to say we can remove the absolute value by saying this, that it's between negative 11 and positive 11. And then to solve this, we'll add 3 to everything. And our answer ends up being v is between negative 8 and positive 14. So when we graph these, we have a negative 8 and a positive 14. They're both open circles. And because it's an and, we just shade in between those two. So anything from negative 8 to positive 14 makes this inequality true. Let's look at another one. Again, we need to isolate this part. So I need to get rid of that negative 7. So I'm going to start by dividing both sides by negative 7. I'm dividing by negative, which now means I need to flip the symbol. So I have the absolute value of n minus 8 less than positive 10. And now I can split it into two separate inequalities. Negative 10 less than n minus 8 less than positive 10. When I split it into the two inequalities, I can take away the absolute value symbols. And then to solve this one, I'm just going to add 8 to every part. Negative 10 plus 8 is negative 2. And that's n, and that's 18. So graphing this on the number line, I'm just going to put the negative 2 and the 18. These are both open circles, and we're going to shade in between. So that's when it's less than. If it's greater than, we split it into two separate inequalities. So again, if we start with absolute value of x greater than a, we can take out the absolute value and say that x is greater than a, or, this is an or, x is less than negative a. So we still have to isolate the absolute value part. So here I'm going to start by dividing by 10. So now I get the absolute value of 3 plus 2v greater than or equal to 7. And now I'm going to split it up into two separate. So 3 plus 2v greater than 7, greater than or equal to 7, or 3 plus 2v less than or equal to -7. And I got that. That's what this means up here. Less than the negative value, greater than the positive value. And now we solve these separately. So take 3, and I have 2v greater than or equal to 4. And dividing by 2, I get v greater than or equal to 2. This one, same thing, take 3, -7 take away 3 is -10. Dividing by 2, v less than or equal to -5. Since this is an or, I know that my inequalities are going to be going in opposite directions. So I have a -5 and a +2. They're both closed circles. Greater than 2 is going to go this way. Less than -5 is going to go this way. So they are going in opposite directions, which they should be because it's an or. Let's look at this one. Again, I need to isolate that part first. So I'm going to add 8. Absolute value of 2x plus 7 greater than 17. And now I can split it up into 2 separate. So 2x plus 7 greater than the positive value, and 2x plus 7 less than the negative value. So less than -17, and I'm going to solve these two separately. So taking 7, 2x greater than 10, and then dividing by 2, I get x greater than 5. Here, taking 7, 2x less than -24, dividing by 2, we get x less than -12. So graphing these, again, it's an or, so they should be going in opposite directions. Let's make sure we did it right. We have a -12 and a 5. They're both open circles. Less than -12, greater than 5. Oh, good, they are going in opposite directions. Let's look at when our answer could be all real numbers or no solution. So again, we need to isolate that part first. So I'm going to start by multiplying both sides by 4. So then I get the absolute value of n plus 5 greater than or equal to -4. If I split this up, because it's greater than, it's going to be an or. So n plus 5 greater than or equal to -4, or n plus 5 less than or equal to 4. Taking 5, we'd get n greater than or equal to -9. Taking 5, we would get n less than or equal to -1. Now, when we graph this, let's see what happens. We have a -1 and -9. They're both closed circles. Oops. I put those in the wrong spots. There we go. -9 should be to the left of -1. So if I look at greater than or equal to -9 means it goes all the way this way. Less than or equal to -1 means it goes all the way this way. So technically, we would be shading in this whole part, everything. So that is why the answer is all real numbers. Also, anytime you have the absolute value of something greater than a negative number like we have here, the answer is always going to be all real numbers. Again, only if it's greater than a negative number. So technically, when I got to this point right here, I could have said the answer is all real numbers. But even if you forget that, once you shade it, you'll notice that you're shading the entire number line, which means the answer is all real numbers. All right, let's look at this last one here. Again, I want to isolate this part. So I'm going to start by subtracting 9. So I'm going to get the absolute value of negative 1 plus a less than negative 11. Since it's less than, it's going to be an and. So I would get negative 1 plus a less than negative 11 and negative 1 plus a greater than positive 11. So if I solve this one, adding 1, I would get a less than negative 10. Adding 1, I would get a greater than 12. But if we graph this, an and is supposed to be squished between two numbers. But if I look at this, I'm going to have less than negative 10 going this way, greater than positive 12 going this way, which does not make sense because it's supposed to be an and, which means it's supposed to be squished between two numbers. That's why it's no solution. Or when we got to this point here, we could have said it was no solution. Anytime you have the absolute value less than a negative number, the answer is going to be no solution. Anytime you have the absolute value greater than a negative number, the answer is going to be all real numbers.